And this is our intelligent monitoring and flushing product. So this is a presentation, a modified version of a presentation that I do at conferences and a number of other places around the country called the Dead End Danger Zone. It talks about flushing and the dangers of water aging. We are coming to you live today from our sampling station portion of our factory. The shift just ended at 1:30, so that's why we set up these things for 2 o'clock. And let's go ahead and jump into the Dead End Danger Zone here. Okay. So a question I get a lot of times from a number of different people is, why do they flush? Why do we flush hydrants? Why do we flush water? I mean, water's water. Why do we have to flush fire hydrants and stuff? Because it's just water. And the short answer is when we add chlorine to water to make it safe to drink and chemically change it, and that water ages, bad things happen. A couple of dynamics happen when water ages. So what does water age have to do with water quality? Well, uncirculating water and distribution dead ends, especially in dead end mains and water distribution systems, can pose a serious health problem for consumers. As uncirculating water ages, disinfection residuals decline, while at the same time disinfection byproducts increase, both of which can create consumer health issues for distribution and water quality managers. So one of the first dangers is this thing called falling disinfectant residuals. So we add chlorine to water to make it safe to drink, but chlorine, just like in a swimming pool, dissipates over time. So when you add chlorine to water, just like you do in a swimming pool, over time it disappears and your residuals can decline. If you look at the chart here, chlorine disinfection dissipates at water ages. A minimum of 0.2 ppm is required as a residual for most states. Most states are at a 0.2, some are higher, 0.4 for Florida. Parts of Louisiana are actually at a 1.0. They've had a battle with a brain-eating amoeba infiltration in several of the parish water systems down in Louisiana, so they've been at a 1.0 for a while. But if you look at this chart, a good yardstick for water quality, especially on a dead-end main, is about 4 to 7 days, about a week, about four days to a week. Chlorine dissipates at a rate of about 1.5 ppm per week after about the first initial 200 hours. So free chlorine stays in the water pretty well, about 200 hours, and then it dissipates very quickly. Chloramines is about half that decay rate. So if you're using a chloramines or a combined chlorine, usually it stays in the water longer. And a lot of the bigger cities and the rural districts will use chloramines to keep chlorine in the water longer. But a good yardstick for water quality, especially if you're doing free chlorine, is about a week, 4 days to 7 days. If my water is less than a week old on a dead end, I'm probably okay. If my water is more than a week old, that's when I start seeing residuals disappear and I start seeing these things called disinfection byproducts start to form. So we want to try and make sure that we're flushing our dead end mains in particular on a regular basis, or having some type of tools out there to monitor chlorine in certain regions and areas of our distribution system, and that's what we'll talk about today. Another threat, once residuals fall below the level, they are unable to control the growth or spread of microbial pathogens. So that's why I put chlorine in water, to make sure that it's safe to drink, kill organisms that might get into the water itself. So a 0.2 minimum is really the minimum strength of chlorine that you need in order to control microbial pathogens that might get into the water system. The other concern about adding chlorine to water and aging is this thing called rising disinfection byproducts. So although disinfectants help to eliminate and control the growth of and spread of microbial pathogens, chlorine controls microbial pathogens. They do carry a serious side effect. I always like to try and relate this to pharmaceuticals. So if you watch TV every night, about every other commercial on TV these days is a drug commercial. And the ones in between are all the lawyers suing the drug companies. But the drug commercials are great because the first part of the commercial talks about how wonderful the drug is and the kites are flying and everybody's having a picnic and everybody's smiling. And then they get to the second half of the commercial that talks about all the side effects. And they rattle off a litany of side effects, and of course the kites are still flying and the sky's blue and everybody's still smiling. It's the same thing with water. We put chlorine in water, it's like a drug. It makes it safe to drink, but when that chlorine comes into contact with a naturally occurring organic material that's in all water, no matter if it comes from the ground or from a reservoir, all water has naturally occurring organic material. When that organic material comes into contact with chlorine, chlorine transforms those particles of organics into toxins that we call disinfectant byproducts. Trihalomethanes, halogenic acids. These disinfectant byproducts, when consumed or absorbed through the skin in the shower or inhaling in the shower, have been shown to cause health problems such as heart disease, liver damage, decreased nervous system activity, so on and so forth. So these are the threats to aging water, and we have some tools that help you figure out where you might have problems with aging water issues, and some devices where you can actually monitor it on a full-time basis. And let's go ahead and jump in and talk about that. So disinfection byproducts can start to form in about 4 to 7 days. So again, a good yardstick for water quality on a dead-end main is about 7 days or less. If my water is less than 7 days old, I'm probably not going to have a lot of disinfectant byproduct issues. If my water is more than 7 days, I might start having these things form in my system. Okay. A good way to take care of both of these situations is flushing. Flushing dead ends is one of the easiest and best methods for improving and maintaining water quality, as it keeps residuals consistently at safe levels while removing water before disinfection byproducts can begin to form. A comprehensive approach to improving water quality should include flushing, tank turnover strategies, source water treatments. There's a number of things you can do to improve water quality. 3 different kinds of flushing strategies are out there. Intelligent flushing, which we're going to talk about today, automatic flushing, and then of course manual flushing, turning on fire hydrants and manual blow-offs. So let's talk about intelligent flushing, what it is. Intelligent monitoring and flushing stations incorporate a built-in chlorine sensor and a PLC that automatically maintains safe residuals and maximize water flushing conservation. Additionally, they capture and provide a multitude of data, including beginning and ending residual levels, flushing times, so on and so forth. So if you're familiar with automatic flushers, which have been out for 12, 15 years now, automatic flushers run on a 9-volt battery handheld controller, and I program usually a day time duration. I'm going to flush Monday, Wednesday, Friday, 3 o'clock in the morning for 30 minutes. And at 3 o'clock in the morning, the valve opens, and at 3:30, the valve closes. So automatic flushers are a good way to turn dead-end lines, but it doesn't provide any data, and you basically program the controller by trial and error, taking hand samples. What intelligent monitoring and flushing does is it takes that automatic flusher and takes it to the next level, where now I have a PLC and a chlorine sensor where I take samples of water, and I only flush based on the residuals that I want to maintain. So good applications for an intelligent monitoring and flushing system include an analytical tool to capture a wide variety of water quality data. We have portable versions of these that you can move and leave around your system to capture data on chlorine, pH, temperature, PSI, turbidity, so on and so forth. And after you collect that data, you can make decisions on what you want to do if you have water issues in a particular area or dead end. Put an automatic flusher there, program it based on the time data that I have from the smart device itself. People who have large mains in their system, hard to hold residuals on, this is a good application for as well. Long mains with few houses on them. We have some systems that use this as a sentry point, where they buy water from another entity and they monitor the quality of water that's coming into their system. So there's a good example of one up in Canada. They buy water from a different city, and when they're getting the water, it's usually around a 0.2 or less. So they actually track their quality of the water that they get through one of these smart devices, these intelligent devices, so that they can charge back anything that's below 0.2. In Canada, you have to maintain a 0.2 residual. If it's below, you have to flush it. So they flush a lot of this water, they charge back the city who provides the water, and they use this system to do all that. Monitoring stations for distribution zones. Many times I go to distribution systems and I see the maps on the wall and they have everything broken down in zones, zones 1, 2, 3, 4, so on and so forth. These intelligent monitoring devices are good for monitoring different zones in your distribution system, so you can see what's happening in different areas of your distribution system with the water quality. And of course, large transmission lines that go from point to point where you need to monitor the quality of the water as well. These are good applications for intelligent and monitoring flushing. So let's take a look at some of the products. We're going to go through some slides here, and then I have a couple of them behind here. I'm going to show you live what they look like and how they perform. So the first set of intelligent monitoring and flushing stations are these ones that we call portables. We have two different types of portable devices that you can use to help make your flushing more efficient and effective. The first one here is called the Flushing Buddy. We call this one the Flushing Buddy because it goes with the crew when they flush fire hydrants. Every system, no matter how big or small you are, flush fire hydrants periodically from time to time, either as a unidirectional or flushing lines for water quality. If Mrs. Brown calls and she says the water smells bad, tastes bad, looks bad, you go and you flush the line. It's usually a fire hydrant or a blow off at the end of the line. So this is designed to go with the crews to make your hydrant flushing more efficient. So it's designed to flush exactly to the parameters that I set. I tell the device I want to flush until I hit a 2.2 residual and a 0.2 turbidity level, and maybe even pH, but most of the time it's for chlorine and turbidity. These are the marks I want to hit. And then when it turns the machine on, it starts, you do the flush from the hydrant, it actually monitors the flush and tells you when to stop, when you've hit your marks. This device and all these devices are scalable. I can have multiple sensors in the device, not only chlorine, turbidity, pH, PSI, temperature, a number of different types of ORP, a number of different types of sensors, okay? So let's take a look. This is what it looks like when it's being used. We have it so that you can either attach it directly to the hydrant itself, or we have a connector hose. We can connect the hose to the hydrant and then move the station away from the hydrant, put it on the back of your pickup truck, or wherever you want to place it away from the hydrant location. So as you can see from the picture here, the device doesn't flush the hydrant. You're still flushing the hydrant in a traditional way. This just monitors the flush so that you can not waste time, not waste money. You set your parameters of what you want to hit on the flush, and when you start the hydrant and hit the run button on the machine, it'll actually monitor the flush and it'll alert you when you've actually hit the marks that you want, so you can turn off the hydrant, move to the next mark, so you don't have to guess. A lot of times I'll be out with crews and they'll be flushing hydrants and the hydrant's gushing and gushing and gushing. And I always like to ask the question, how do you know when you're done? I mean, really, how do you know when you're done? A lot of times for chlorine, they'll take hand samples. But for turbidity, it's kind of a guessing game. I usually hear the white bucket or the white cup method, where I get a little water in a white cup and I say, see, yeah, it's a little cloudy. See, we're going to flush a bit longer. But they really don't know what the turbidity level is. It's kind of a guessing game. It's an eyeball. So this will actually measure the turbidity and tell you when to turn the hydrant off. My favorite all-time answer I ever had when I asked someone, how do you know when how long to flush? How do you know when to stop? Was a crew that told me that they use the 2-cigarette method. I turn on the hydrant, I smoke 2 cigarettes, and I close the hydrant. So that was the system that they had in place, which I thought was interesting. So the spec looks like this. This is how it looks like when it's either attached to the hydrant or attached with the cord. This is called the Flushing Buddy. It makes your hydrant flushing more effective and more efficient. The device is powered by a 24-volt lithium-ion battery that you recharge, okay? It has a touchscreen PLC, and it flushes the exact amount of water to reach the programmed desired levels that you want to hit with your flushing. The other thing, too, is when you capture your data, you'll pull the data off this machine and you drop it into pre-formatted spreadsheets. You can put it in your SCADA system. You can put it in a GIS program. So that's the nice thing about this. This one I'll demonstrate here at the end to show you how it works. But when you dump your data into pre-formatted spreadsheets, it creates charts and graphs for you automatically. So these are examples of the charts and graphs that you get when you drop your data into the pre-formatted spreadsheets that we provide for you. So the Flushing Buddy goes with the crew. Another portable device that's very effective, this is an analytical tool. This one's called the 9700i Solar. And the 9700i Solar attaches to a fire hydrant. And I'll show you this one here at the end of the session as well. So I attach it with a 2.5 NST connection. This device is a little different than the Flushing Buddy because the crew's not here. So what I need to tell this station is, I want to maintain a residual of, let's say, a minimum of a 0.15 and a desired level of a 2.0. So I set the parameter of residual that I want to maintain. And then I schedule sampling. I want to sample the water twice a day at noon and at midnight. And at noon and midnight, the device will turn on. It'll flush some water to get some flow going through the flow cell. It'll actually take a sample of the water. It'll measure what the chlorine residual level is. If it's below the 1.5 that I want, it'll flush the exact amount of water until it hits 1.5. Again, it captures all the data. Everything that just happened in that scenario will capture data. From this device and other devices like this, it actually transmits the data directly from the station to a SCADA system, a laptop, your phone, wherever you want to send it to, using an RV50 wireless gateway. So this one actually transmits the data. So if you have a large system and it's 30 minutes away to get a drive out to where this thing's at, you actually can get live readings right from the station itself as it sends you the data, okay? Another nice thing about this device too is I leave it in a spot and I capture a number of information about residuals, turbidity, so on and so forth. And it'll tell me exactly how long the device is flushing to maintain that parameter or residual that I want. So I get the data back and I decide, you know, I need to put an automatic flusher on this dead end because we're having residual issues. I put the automatic on the dead end and I get ready to program the controller. And what I do is I take the data from the data sheets that I got from the machine. They'll tell me exactly how much down to the second I need to program the flusher to flush. So I'm very efficient with my automatic flushers based on the data that I get from this device that I can move around my system. So I leave it here for a few weeks, I move it someplace else. So this is a portable analytical water quality tool that I can move around my system and capture water quality data from. And then based on that data, I take actions on doing other things like putting in a booster station, putting on automatic flushers, whatever it might be, okay? This is what the spec looks like and how it fits on the hydrant. 2.5 inch NST connection. It has a solar power recharge, 24 volt lithium ion batteries, again, solar recharge. This is the device you need to bring in the wintertime. So this one has a valve above the ground. So when the winter comes, this one has to come inside because it will freeze. We did have a gentleman in Illinois who let this stay out too long, and he had a beautiful ice sculpture coming out the bottom of the box, but it didn't crack the valve, luckily, and he got it in time before it caused any damage. So those are portable monitoring and flushing stations. They monitor the water quality, and then the portable one on the right actually flushes the line automatically based on the data that it acquires from the samples. We have a couple of permanent stations. These are stations that I would actually tap to the main with the 2-inch connection. The first one is the one that we sell a great deal of these. This is a very popular item. It's called the Genesis, the Eclipse I-Series 9800i Genesis. And it's called the Genesis because it creates its own power. It creates its own power using a water turbine and a battery bank. So with this one, I don't need any 120 line power, no solar. It actually has a 24 VDC battery bank in the enclosure, and the water turbine actually charges the batteries, runs the heater, and operates this station year-round right off the power of the moving water off the water main. So the nice thing about this station, I can literally put it anywhere I want because the main is my power source. I don't have to have a southern exposure. I don't have to be near 120 line power. It actually powers itself right off the water main, okay? It has a high efficiency fan heater, so it heats itself in the wintertime. R9 installation. When you box it all up, it just looks like a big electrical transformer box, a big green box, about 4 by 4 by 4, okay? This one does the same thing like the portable. I set my parameters of residuals I want to maintain, my turbidity, and it takes samples and it'll flush the lines until it reaches those parameters that I want, captures the data, transmits the data just like the portable one as well. Same files that I can drop into my spreadsheets and create the same graphs and charts like the other one. This is what it's going to look like in the ground. These are two examples. One on the top is a station that was installed several years ago, probably 5-6 years ago, up in Wisconsin, very cold place. We have these as far north as Toronto, Massachusetts, Wisconsin, and they run year-round in the cold weather. This was a dentist's house, and they were having water quality issues. It was a neighborhood that had a lot of large houses, a large main, and not a lot of use of water, so they had to turn the water. So they put in this really nice one. They landscaped it, made it look very nice in this gentleman's front yard. The one at the bottom here is an example from Nashville, Tennessee. Nashville, Tennessee put in several of these, and what they did is they put them on the corners of their distribution system. and they figure if the residual is good on the extreme, it's probably good in the middle. But they also use automatic flushers and dead ends. But they monitor the water quality right out to the edge of their system. So this station here was located way out in the middle of horse country in the far suburbs of Nashville to the southwest of the city. And they just installed this one in the ground. So it didn't have to look pretty on this one because it's out in the middle of nowhere, basically. But again, since it powers itself, they can actually put it wherever they want because it powers itself right off the water main. So this is the Genesis, creates its own power. The 9800i is the same thing as the Genesis. It's just a smaller footprint. Does the same thing, but this one requires 120 line power. So if you do have 120 line power nearby and can utilize that, you can have a smaller enclosure and you don't have to worry about the power using the turbine and battery banks. We can actually hook this up on 120 line power. There's all the same things that we talked about with these other stations. This one just uses 120 line power instead of creating its own power like the Genesis. If you're living in warm climates, we have a couple of choices like the cold climates. We have one that's a solar power rechargeable station. So these are for warm climates that do not have freezing issues. We have a automatic flusher attached to the pole-mounted intelligent device. So all of your electronics and sensors are inside the box, recharged with the 24-volt lithium-ion battery. Again, captures data. I set my parameters what I want. It'll take samples. It'll flush the exact amount of water. So this is a warm climate version that flushes like the other ones, but we don't have to worry about freezing. And then its counterpart is the 9800 WCI. This one would require, again, 120 line power. So if you have 120 line power, again, all you need is just a smaller footprint. You don't need the post with the solar panel, and you can operate this one as well. Okay, so these are all different types of monitoring and flushing stations that you can set up in different parts of your distribution system or use the portable ones to maintain and monitor water quality. A few other devices that we have in the series, we have 9 or 10 different products in the series, are monitoring stations only. We've come across a number of systems saying, well, I don't need the flush, I just need something that will monitor the water and send me the data. So we have monitoring only stations. A few of these here. This one is probably the one that we sell the most. This is one that actually mounts on a wall inside of an existing building, like a pump station or a booster station or a public building, someplace where I can get access to power and water to hook up to, and it has heat. So it's an indoor installation. So basically what you see here in the picture is the way it's going to come to you. Mounted on this black backboard, I basically take it out of the box, I mount it to the wall, I hook up my water, I hook up my power, I get my sensors calibrated, and I'm ready to go. One thing with all these devices for intelligent monitoring and flushing is if you decide to purchase one of these in any capacity, whatever is the Flushing Buddy or the portable or the Genesis, what's included in the price is an on-site engineering visit, where our engineers will come on site, they'll help commission the statement, get it up and running, but then they'll also do training for your folks who are going to be the ones maintaining and using these products. We always recommend, if you're going to get these types of products, to nominate 1 or 2 people who become the experts. And they're the ones who we can train, and they're the ones who monitor and do the maintenance on the products themselves. The other nice thing about these products is they're all set up, except for the Flushing Buddy, with an RV50 wireless gateway. So if you're having issues after you get these things running, since it's an RV50 wireless gateway, our engineering staff can actually get online with you, see your PLC, and help troubleshoot any issues they have right online. We don't have to send one out to do these types of things.
Dan would like to talk about that.
Dan Lawrence?
Yeah,
okay.
Dan Lawrence.
Pipe in, Dan. Here. This is our engineer, Dan Lawrence.
I'm going to share my screen right now for a second, Robert.
Okay.
You have to stop your share real quick,
right.
though.
I'll do that. Go right ahead.
So this is, I got 5 million things open. That is the wrong thing. Those are oscilloscopes. That doesn't interest anybody here. So what we're looking at on this one is actually a customer in Columbus, Georgia, that they've got a military base. And out on that military base, they selected key spots throughout the base And the one in the lower right that you're seeing is what we call the master. They did not want to tie their flushers directly into their SCADA system, so we basically created a mini SCADA system using their flushers themselves. And so these are as if you were standing directly in front of the unit. You're looking at, well, let's see, that one had funny readings from the analyzer. But that's a live reading from Columbus, Georgia, and the PLC is as if I were standing in front of it. All the buttons work. I can change my residuals. I can turn on and off the valves all remotely, as if I was at the site. But it just, and so what we're looking at here is the traditional numeric display. All of the standard iSeries now come with a HMI touchscreen, which actually helps with the interface. The buttons all work on this screen. I'm not going to touch it because it's sitting on their desk in their office. So, but this one is just the master one that just calls all the other ones. It cleans up the user interface a little bit going to the touchscreen display. But that's all I got on that, Robert.
Okay, go ahead and stop sharing. I'll jump back.
Yep.
And that's the nice thing about having the RP50 wireless gateways is a good example is let's see, share screen. We'll go back to here. A good example is we're dealing with this COVID situation, and we had a system up in Massachusetts that wanted to commission their unit and do training, but they didn't want us to come personally to the site. So Daniel did one online, basically did a commissioning online with that particular customer. So again, having the RV50 wireless gateway is good for you in that you get that information automatically, but also for troubleshooting and support, we can piggyback on that as well.
And Robert did not mention that the cost of the data for 2 years and the actual device itself is all built into the cost of the flusher.
Yeah.
That if you wanted to take the data off, you could easily do that and put it on your municipality's plan. Typically costs a couple bucks per month. I mean, you're talking about 4 or 5, maybe it depends on how much you're accessing it and how much data you're sending to and from, but you're typically anywhere between $4 and $15 a month. 15 being that I'm calling this thing and asking for constant updates on levels and statuses. That we have not mentioned that the 9300 IMB that Robert has on his screen right now, smaller municipalities sometimes look at this as potential SCADA solutions for pump stations and well houses where they might not have something in place. Being a open-ended design, it allows us to modify the PLC and control outputs, valves, VFDs, whatever the customer needs, as you know, as is needed for them. And being an out-of-the-box solution, it's significantly cheaper than what it would cost to, you know, go start to finish with a consulting firm from the beginning to end.
Yeah,
So.
Good, awesome. Okay, let's jump here. Any questions that anybody have right now that they'd like to ask? And I'll show you a couple of examples of these stations. Okay, so this is the flushing buddy, and this is the one that goes with the crew. So again, a portable device, has a quick disconnect on the back here that you hook up your hose to, and then we have a 2.5 NST quick disconnect that goes onto the hydrant itself. What the crew would do when they get to the station and they hook this up to the hydrant before they turn the hydrant on, is they'd want to designate what hydrant that I'm at. Okay, this is through your GIS program. So when I flush a hydrant, I want that data to go to the hydrant that I'm flushing. So I'm at hydrant 635. So again, the touch screen, like Daniel talked about on here, is a kind of a glare. So anyway, did it any better than that? Let's see. No. on the screen, there's a button you'll hit, and you'll actually punch in what hydrant I'm at. I'm at hydrant 635. I hit enter. And then you touch the screen and put in the residual or the NTU for turbidity that I want to hit. I want to flush this hydrant until I hit a 1.5 residual and an NTU of a 0.2. And you hit enter. And then when you turn the hydrant on and start flushing, we hit this run button. And on the screen here, you'll actually see your live readings like you just saw on Daniel's screen, where it shows you what the live readings are. And you'll see the residuals going up and the NTUs going down as the hydrant is flushing. So you can actually watch it live of where your readings are as you go along. When it hits the marks that you're supposed to hit, this is what the crew is going to see in here. So the light will flash, the beep will go beep, 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 and it tells them exactly when I've hit the marks that I want to hit on this particular flush. Captures all the data that just happened and saves it to a solid state on the PLC, solid state PLC, and then I can actually take it back. Since this one goes with the crew, we don't have the RV50 wireless gate with this. It doesn't need to transmit the data because I'm taking it back and forth all day long, every day when I go flush hydrants. So the crew takes it out and the crew brings it back. So all of our devices, you can actually pop a micro SD card here on the PLC, and we have adapters to slide into your USBs in your computers, and you can drop that data into your GIS program and map all the flushings that crew did by hydrant. So every time they do a flush, over time you'll see that hydrant, you'll see a history of the flush from this particular data that's dumped in there. Runs on a 24-volt lithium-ion battery that's rechargeable. I can hold up to 8 sensors in here. So, and it's scalable. So I can start with chlorine, and then I can add a turbidity later. I can add a pH later. It comes with temperature and PSI automatically. So chlorine, PSI, and temperature are the automatic 3, and then I can add other things as I move forward from there. Okay. So this is called the flushing buddy. The flushing buddy goes with the crew when I'm flushing fire hydrants. Everybody flushes fire hydrants. This makes your flushing much more efficient and effective when you're flushing fire hydrants. It has a battery power gauge on here so you can see what your battery's at. If your battery's running low, plug it in the wall. It'll take about 30 to 45 minutes. It'll fully charge. It'll last 4 or 5 weeks out in the field if you're using this thing all the time. Another device that we have is the portable. I'm going to turn my screen here so you can see this one. This is the portable one that fits on the fire hydrant. The only thing that's not on here is the solar panel at the top. It's just too bulky to deal with. So there's a solar panel on the top like we saw in the picture, and the water flushes below the box here. So this actually, again, a 2.5-inch NST connection. I connect it right to the fire hydrant or the blow off. Up here at the top portion, we have all of our electronics and our sensors are up here in the top portion, and on the bottom is your flushing section. It actually flushes the hydrant with the 2-inch automatic flushing valve. So this is one that you can move around your system, program it to what you want to do. I want to maintain a 1.5 minimum, a 2.0 desired level, an NTU of a 0.2 with a desired level of a 0.1, and then it'll actually run the scenario with sampling schedule that you want. A question I get a lot of the times is say, what if I don't want to flush during the day? How do I keep this device from flushing during the day, taking samples? And the answer is you program the sample taking during certain hours that you want to actually have it flush. So if you don't want to have it flush during the day, I take all my samples between midnight and 6 a.m. And if it takes a sample and it needs to flush, it'll flush the line. But it won't take any samples any other time that you don't want it to flush, in case you don't want the water running down the street or wherever it might be. So this is an analytical tool that you can move around your system and gauge water quality on a number of different water quality aspects, pH, PSI, temperature, so on and so forth. Capture data, and it transmits the data right from the station to your cell phone, your laptop, your SCADA system, wherever you might want to have that water go to. So these are just 2 examples of the ones we looked at on the slides. We have the permanent solutions for warm and cold climates, and then the portable solutions that you can use with the crews that are going through the fire hydrant. Any other questions? Any questions everybody have? Yeah.
Question is, do the intelligent monitoring and flushing devices work for the utilities using chloramines as well as free chlorine?
Good question. With the chlorine, you have a choice of 3 different sensors. You can do free chlorine, combined chlorine, or total, okay? We do have some systems around the country and in Canada that do what we call a free burn. So they're using a combined or chloramines most of the year, and then they switch over to a free chlorine for a short period of time to burn out biofilm and so on and so forth in the pipes. So they actually swap sensors in and out depending on what they're doing at those times. What we do offer standard with the unit is a free or combined chlorine, and then there's a little bit of an adder charge for the total chlorine. So we can do any of those three. Daniel, any other input you want to have?
I mean, it just, the designs are, between all the I-Series products, over the 10 years of development, we've really worked to streamline the designs and make them scalable and interchangeable between them. You know, the sensors are to this point where they're Modbus sensors, and you can plug and play pretty much any sensor into any configuration. That if you wanted to study ORP in your system and you had 13 of these devices, you know, financially, it would make much more sense to buy one sensor and move it around rather than just straight up implement the cost of doing that sort of study across the board.
Okay. The other thing we can do, especially with the Flushing Buddy and the portable device, is if you want to see a live demo, we can do live demos where we can bring one of these out when the time comes and hook it up and show your crew how it works. Actually do a live demonstration on a hydrant if you want to see how this actually operates in your system. So that's another option that we have. Of course, when the COVID thing kind of goes away and we're allowed to go out and about and see each other again, that's an option that we have as well. Anybody have any other questions?
I got that question.
Okay.
The 9800 WC, the 24 LIS
Yes.
pedestal, what's it take to upgrade a standard 9800 WC to that unit?
Well, if you have like a regular 9800 WC.
Yeah, and somebody wants to flush off.
Here's a good question, Daniel. So I have a 9800 WC in my system, and I want to make it a 24 LIS intelligent. It'd be pretty easy to do that, wouldn't it?
Yeah, I mean, all you'd have to do would be to drill and tap your existing flusher before the valve, and then run a little bit of conduit over from the control pedestal for the controlling the solenoid, and you've essentially turned it into an intelligent flusher. We could go so far as, you know, if you didn't want to drill and tap your existing flusher, we could put a coupling on a valve assembly and send another one with detailed instructions. It's a pretty fast and nasty, as the old machinists used to call it, way of getting from point A to point B.
Okay. No other questions? I will say thank you very much for joining us today. If you have any other questions, you have my email. You can talk to me offline. And I appreciate your time today. I hope this was of interest, and we look forward to seeing you hopefully sometime here this year, actually on the road. So for now, we'll say goodbye. Thanks so much.